Hello friends, welcome back to the bench. Thank you very much for joining me. Our patient is a b2600i, 91 to 93. We also have two that are from 89, also b2600, but without I. So what they use carburetors, but it's not a carburetor that I'm used to. It's basically it's controlled the same way you control injectors, but instead of direct injection into the cylinders, you just control the carburetor. So you still have the same lines. There's a solenoid in there, and it is controlled with PWM as far as I understand. So we're gonna have to figure out how to fix that one. But this one came with no description of the issue. So we don't know what's wrong with it. So we're gonna have to do some guessing and some inspection and stuff. It has been recapped in the past. And it was done pretty well because they also replaced this cap, right? And I'm not sure here. Now it hasn't been cleaned, so there might be some corrosion. Yeah, and it hasn't been sealed after the repair. So see, I had a question in the comment recently, like, do you have to put conformal coating back on the ECM? Is that important? Well, in my view, it is, because after you repair it, you don't want to see, you want to stop the corrosion. Right, this is not sealed. Oh, and what is that? This isn't sealed, right? It's not inside the car, so it's prone to, humidity and all that kind of stuff. So what do I see here is this suspicious thing. What is that? So this is a piece of metal that was being used probably to create the bridge to restore the trace. And looks like it got left behind. Interesting. Okay, so I wasn't showing you. So this is the cap that we normally replace. The diode seems okay. Not much corrosion over here. They replaced this cap, which usually people don't replace. So I'm glad to see that. We're gonna check the caps, but first we need to figure out what's wrong with it, because we don't know. So let's check our favorite two transistors responsible for injectors. Let's do the diode. So first let's confirm that we have a ground on the meters. We have ground on the meters. Good. Collectors are open. Good. And we have 260 and 260 on bases. So this is good. So now we want to make sure that the base is making it to the transistor. So this one is good, and this one gives 0.3. So good. And does the actual transistor get connection? It does. And let's see the other one. And we have the connection. So injection seems to be okay. Let's see the ignition. So let's compare to ground. It's emitter 1.3, 0.5, and 0.8, 0.9. So good. Ignition seems okay. Injection seems okay. So these are the typical two culprits that normally render your truck unusable. We definitely have a melting to the cap. That's not ideal. And now, how did this happen? This happened because, because when this cap was being replaced, well, at least they put 105 cap, so that's good. The soldering, the soldering is. So when this cap was being soldered, probably the soldering iron came from this side to put that big blob of solder over there, and we melted the cap. It happens. So these caps are gonna be replaced. Now we need to give it a good cleaning as well before we do anything more, but it's a little nasty over here. Yeah, okay, so the conformal coating doesn't seem like it was removed before soldering. That's why it looks so bad. So let's check via to via. We good. We good. Now this diode is in 0.5 in this direction and 2.7 in this direction. So the diode is fine. Now that old conformal coating probably doesn't have much to do with this. But since we have injection and ignition, there's not much more we can check over here other than the corroded vias, of course. I have something here that is suspicious. Looks like it should go to this pin. Yeah, I'm not sure about this via here. Maybe it's good, maybe it's not. For some reason, people or technicians that do this are notorious for installing the caps away from the board. I don't know why, but that's what they do. And the cap is in not bad shape. It's acceptable. I mean, 300 milliamps of ESR and 0.7 of VLOS. It's, you know, for certain applications it would not be okay. Oh, this isn't 105. This is 85. So that's weird. Yeah, this is 85. So they replaced the other cap with a lot better cap, but this one, which is more important objectively, they replaced with the same capacitance but 63 volts. This should be 25 volt cap. You can replace it with 50. Sometimes I do that when I don't have the 25. But overall, you know, if it came with 25 volt, you should replace it with 25 volt. Let's see the other side of the board. Okay, so conformal coating is falling off by itself. Now it looks like, yeah, well, the soldering is probably the worst one we've seen so far on these, like so. So we have a big blob of non-shiny solder, right? It looks like the flux was not being used. This looks like just a rosin core that melted from the solder. So that's why. I mean, it looks like it would work, but no, you can put big blobs like this. And I don't know if this was cleaned. Yeah, it looks like they just sprayed it with a little bit of alcohol, maybe gave it a little bit of, you know, brushing, and left it like this. So sloppy work, but you know, if it works, that's all we care about, right? This is not bad. See, this is the right amount of solder. Just clean the conformal coating. But here, not so much. Not enough solder. Probably that's why the big blob at the top. Could be. And what is this? Looks like there was some heat over here. And it looks kind of like conformal coating mixed with flux. But why would there be heat over here? It's weird. Okay, with no description of the issue, what we have to do is just clean it. We're gonna do the vias just in case, because some of these just kind of look not great. I mean, it passes continuity test, but that's not all. We're gonna replace these caps. We're gonna replace this one and obviously this one, and we're gonna give it more inspecting after the cleaning. Maybe then we'll see something. And sometimes, yeah, once we remove these caps, one time, remember, we found the broken trace underneath this cap, but that's very unusual. Happened once. All right, let's do some cleaning and see where we can get this. Alrighty, we are done. It's super clean now. So what I noticed actually is a very unusual fault. There's gonna be a little pounding in the background. My wife is making schabowe. Yes, she's Filipino, but she knows Polish cooking. We've been married for a long time, so she's an excellent Polish cook. Anyways, so that cap, this one over here, right? That's why it was kind of, someone tried to solder it at the top. That's why they melted those caps, because the via is broken, right? And in this case, our power supply comes in here, and there's a big plane, right? And it goes to that cap, right? So that cap is on the main power rail. But if that via is broken, then our 12 volts doesn't make it to the other side of the board. And this is the only, well, maybe not the only via that it transmits the power between the two sides, but for this little power where we power the ignition transistors, no, not ignition, injection transistors, they likely were just not powered, and that was the problem. I think that's what was wrong with this one. Now it's important because we checked the low and high side transistors, right? They are pulled up and everything. But if the ignition still doesn't work, there might be a 5-volt rail missing. And we need to have 5 volts over here on these two resistors. So these two resistors, they are pulling up the gate or the base of our main injection transistors, this one and this one, right? And as I said before, the MCU is pulling it down using these two transistors. So they are always open, and the MCU turns them off. So if they're stuck open, we don't have a connection or something's wrong over here. But if everything is okay over here, and I measured and everything's fine here. But if they don't have 5 volts over here, then even though this side is working, there's no injection, right? Because the transistor never opens, because MCU only controls closing. So let's do a quick test. So let's connect power like so, and ground like so. Okay, and let's grab a thermal camera, and let's see if everything that should turn on turns on. And we should be grabbing roughly 230 milliamps, about 2.7 watts, below 3 watts. This without ignition, because we're not going to send the ignition signal because we don't need it. So what we want to see getting hot is IC3. IC3 is responsible for generating 5-volt rail between the other stuff, and we want to see a faint heating up from the MCU, because MCU will turn on. And few resistors are gonna get hot, and that's all we want to see. And so first, I'm limited to 300 milliamps. If it grabs all 300 milliamps, we have a short somewhere on the board, and then we just need to see what's getting hot. If it's grabbing correct power, 228, 226 milliamps and 2.7 watts. Now, yeah, our 5-volt rail IC3 is getting hot. It's at 36 degrees, so it's okay. If it's growing higher, then we have a short. The IC5 is dead cold because we don't have the ignition signal turned on. And that provides the essentially it still wouldn't get hot because we would have to connect the load. The main power rail transistor over here is getting warm, 33 degrees, perfect. And the MCU perfect. Nice faint signal. You can barely see it on, especially on a small screen like this. You can barely see it, but that's what we wanna see. These MCUs, they don't take much power. They work on really low frequency, so they don't consume. It's not like on Subarus or the newer Subarus. Okay, so this is all good. Thermal image looks okay. Power consumption is okay. So now let's just confirm, although I'm pretty sure this is definitely going to work. So let's check the two resistors that we need for working injection, and we have 4.99 volts. So 5-volt power rail is fine. 12-volt power rail is fine. So everything is fine over here. So I think that was the problem over here. It was just messed up on this capacitor. That was the problem. Now I'm not too happy with how it is connected now, because it shouldn't be floating like that. And that's what I always complain about. But in this case, I just couldn't do anything else. Let's call it was already broken. So I had to live with that brokenness. But it looks like everything is fine. So let's seal it, ship it back, and if there are any problems, let me know. Just be more specific what exactly is wrong. But I don't see anything else wrong over here. I also did all the vias and everything that looked suspicious. I just reflown it. The damaged cap is replaced. Electrolytes are replaced. Everything looks good over here. Alrighty. Thank you guys very much for watching. I hope you found this useful, or at least a little entertaining, and I shall see you guys in the next one.